So in this example, they give you a complicated left side of the equation, and they want you to simplify it to the right side of the equation. So this is a true statement. Secant of an angle plus tangent of an angle times 1 minus sine of an angle equals cosine of that angle. Yeah, it's a weird statement, and they just want you to show that it's true. Show that it's true. So first, you're going to start with the left side of the equation, and you're not going to write down the right side of the equation. We're just going to use the left and try to create the right. First thing is you can either change things into properties or you can do algebra first. I'm going to do algebra first because there's some algebra that looks like we should start with. So what algebra do you think we should do? Think about that. When I see the problem, I see that we can FOIL this. We can distribute. So the first step that I'm going to do, and there's all kinds of different ways you could do this problem, but the first thing I'm going to do is distribute secant and then distribute tangent. So my first statement is equal to secant times 1, which is secant, secant times negative sine, which is negative sine secant, plus tangent times 1, which is tangent, minus or plus tangent times negative sine, which is negative sine tangent. The order doesn't matter, I just like sine first. So I took care of an algebra step. I saw that there was 2 parentheses that could be FOILed, so I FOILed. The next thing I notice is that if I want cosine at the end, always keep an eye on your end goal. If I want cosine at the end, then I'm going to want cosines in this problem. So I'm going to go through and try to get cosines out of these. So I'm going to go back to my properties, go back to the properties from earlier in the notes, and see if there's anything we can change into cosines. So first thing I notice is secant is the same thing as 1 over cosine. So I'm going to change secant to 1 over cosine. I'm going to do that here as well. So I'm going to use that same property twice. Sine does not easily change into cosine, so I'm not going to change sine. Tangent does not easily change into cosine, but I'm going to change it into this one where there's a sine and a cosine. And I'm going to do that for both of these tangents. I'm going to use that property for both of these tangents. Now, typically what I do when I solve these problems is after any algebra steps, I always try to change everything into sines and cosines. In this case, I want cosine at the end, so I definitely want cosines, but sines are okay as well because more than likely they will cancel out for us. So I'm going to change everything into those 2 properties. So now I'm going to rewrite. So line 3 of my proof, secant is the same thing as 1 over cosine. Sine I'm leaving alone. Secant is 1 over cosine again. Tangent is sine over cosine. Minus sine I'm leaving alone. And tangent I'm changing into sine over cosine. So I substituted in those 2 properties that I told you about earlier. Now we've got this. This is our proof so far. Now we're going to do some algebra stuff. I'm going to combine fractions together. So I'm just going to rewrite this so it looks better. 1 over cosine minus, I'm going to combine these. When you multiply fractions, you just multiply top and bottom. Sine has an invisible 1 on the bottom. So this is the same thing as sine over cosine plus, we have sine over cosine, minus, and then here I've got sine over 1 again. If you multiply the top, you get sine squared. And then if you multiply the bottom, you get cosine. So I went through each of the 4 terms in combined fractions with multiplying. Now, I've got 4 fractions that I'm adding and subtracting. They have common denominators, which is good. Sometimes you have to get common denominators, but here they already have them. So that means I can add all these fractions together. So my next step is to add fractions. And when I look, these match. Sine of cosine and negative sine of cosine are opposites of each other, so those fractions cancel. So if I subtract these, if I subtract the numerators, I get 1 minus sine squared. And when you add and subtract fractions, the denominators stay the same. This is where I am now. Remember, my end goal is cosine. I just want cosine at the bottom. So that clues me in that the top needs to simplify because it's still sine, and I need cosine. So then I'm going to go back up to my properties and try to find a property where I can get rid of sine squared and somehow get cosine out of it. So look at your properties. Which one do you think it is? And what you should find, it's this one, your Pythagorean property. So your Pythagorean property you can reorder in whichever order benefits the problem. So for example, this one, I want 1 minus sine squared in my problem. So if I subtract sine squared to the other side, then this property would say cosine squared equals, if I subtract sine squared on both sides, 1 minus sine squared. So that means this 1 minus sine squared, I can substitute in cosine squared in its place. So that means down here, 1 minus sine squared is the same thing as cosine squared. So I substitute that in. Now look, I finally got to all cosines. Remember at the end, we want just one cosine. Since we have cosine squared and cosine to the first on the bottom, one of them cancels. So you're canceling out the square, because this is the same thing as saying cosine squared. You don't have to write this part. I'm just saying why it canceled. Or it's the same thing as cosine times cosine. So one of them canceled, and that's how you get cosine theta. So we did what it said. We showed that that equals cosine using our properties one step at a time.